In this video, we're going to learn how to do the derivative of natural log of a function, ln of f of x. Before we do that, I need to make sure you remember certain things about natural log of x and its inverse e to the x. So in your notes, you should have a little slip of paper taped down just to save you some writing and to help you with the graphs. So make sure you title your notes here, the correct name here so you can find it later, and make sure you're on that little slip of paper. Natural log of x and e to the x, remember they are inverses of one another, and because they are inverses, it means their graphs are the same exact shape. They're just reflections of one another over the line y equals x. This is not an asymptote, it's just an invisible line of reflection. So if this was e to the x here, and then that's natural log of x, if you were to fold the paper on this line, it would be the same exact thing. So beneath, for me, it's beneath it. For you, it's next to it. These are all rules having to do with natural log of x. These are all rules having to do with e to the x. Just realize that natural log of x has a vertical asymptote right here at x equals 0, whereas e to the x has a horizontal asymptote at y equals 0. That's why natural log of 0 is undefined. It has that VA. Natural log of e to the x, because they're inverses, they cancel. That only happens because natural log has an invisible base of e. If the base of the logarithm is the same as the base of the exponential, they cancel, leaving you with x. And it won't always just be x, or it could be a function. So natural log of e to something is just that something. Here are the rules for e. Again, e to the natural log of x, because the bases are the same. They cancel, leaving you with x. So pause the video, make sure you have that all written down there. And then I'm going to show you a few properties that you learn in Algebra 2 that might come in handy whenever you do derivatives. So they can make taking derivatives simpler. And those are here. This is just commenting that these two rules are true because of the inverse property of the two graphs. So they undo each other, inverses. All right, so these are the properties you want to fill out the bottom half of that slip of paper. These were rules for expanding and condensing. So if you think back to 10th grade, around springtime, you were expanding and condensing logarithms. These you learned in Algebra 1, probably basic exponent rules. We're just doing them with e here. Write these down. They should come back to you. It's only for multiplication and for division. All right, so let's get to some derivative stuff here. Before I do examples and before I tell you what the rule is for the derivative of ln, I want to build up the proof of what it is. This is a little proof. There is proofs for everything in math. It's just some of them are so complicated, they're beyond the scope of this class. But this is a quick proof, and it's neat to see. It shows you exactly where the derivative of ln comes from. So we're going to start with a basic statement. E to the natural log of x is x. That's something we know is true. It's because they're inverses of one another. What I'm going to do next is do the derivative of each side. Algebra rules, I'm allowed to do that. That's what d dx means. The right-hand side, well, I know what the derivative of x is. It's just 1. I'm not touching the left-hand side yet. All I did was rewrite the left-hand side here. So now let's actually deal with the left-hand side. I'm going to keep the right-hand side the same, but I want to do the derivative of e to the ln of x. I know what the derivative of e to something is. It's just e to something. But now I'm supposed to multiply by the derivative of that something. Well, I have no idea what the derivative of ln of x is. That's the whole point of this. So I'm just going to write, okay, multiply by the derivative of ln of x. It's good enough for now. This is what I'm ultimately looking for, the derivative of ln of x. So let's try and isolate this, and then maybe we'll have the rule. We already know what e to the ln of x is. We just did it right here. E to the ln of x is just x. So now I have x times the derivative of ln of x. And what I'm going to do now is just basic algebra rules. If I want to isolate this, the only thing keeping this from being alone is that x. So I'm going to divide both sides by x. And then I'll have the derivative. So it's very quick. It's pretty neat. So I can therefore say the derivative of ln of x is 1 over x. I just divided each side by a whoop, divide, divide, it cancels. All right, so there is another derivative rule for you. And down here, I think I have it a little bit neater. Oh, maybe I don't. Maybe it's over here. There it is. Okay. So the quick rule is that the derivative of natural log of x is 1 over x. So if you didn't copy that down from before, make sure you have that written down. However, we always have the chain rule now. So this is the more applicable rule because it covers every situation. If I have natural log of something, it's going to be 1 over that something times the derivative of that something. So chain rule here, this is the inner gum, this is the outer candy in blue. You can't get to the gum until you take care of the candy. If you multiply these two fractions, so this is really f prime of x over 1, then you get f prime of x over f of x. So this is the more condensed rule. So make sure you have that written down neatly in your notes. Put a big star or circle around it so you know it. And let's use that rule to find some derivatives. So I have 5 examples. The first 4 are pretty quick. The last one's a little bit more involved. So I want the derivative of this. That's a derivative with respect to x. So ln of x, the derivative of that is 1 over x. So 1 over what I'm doing the natural log of times chain rule derivative of whatever I was doing the natural log of. Well, derivative of 5x to the 7th, bring the 7 down, it's 35x to the 6th. And the derivative of 2 is 0. So that was a chain rule right there. So 35x to the 6th over 5x to the 7th plus 2. If I'm just going to multiply the two together. You should clean it up a little bit, write it as one fraction. Don't leave it like this. It's neater like this, and if anything cancels, then cancel it. Okay, derivative of natural log of sine of x. So the derivative of natural log of sine of x is 1 over whatever I'm doing the natural log of times the derivative of this. Derivative of sine is cosine, and that equals cosine of x over sine of x. Well, think back to pre-calculus. Cosine of x over sine of x is cotangent of x. All right, so that one simplifies nicely. Oh boy, what am I doing? Eek. Okay, number 3. Natural log of 5e to the x squared. Now be careful here. I have an e. We actually have like layers upon layers. So within natural log, I have this, and then I also have this. Okay, so let's take this one slow here. I have to do the derivative of natural log of this whole thing. So let's just start by doing 1 over that whole thing. Okay. Now I have to multiply by the derivative of this. Well, the derivative of, remember, 5 is a constant. It's along for the ride, okay? Derivative of e to something is just e to something. But it wasn't just e to the x. It was e to some function, which is x squared. So now I have to multiply by the derivative of x squared, which is 2x, okay? That kind of had 3 layers, actually. Notice we have some canceling here. I have 5e to the x squared on the bottom and 5e to the x squared on top. So all I have left is 1 times 2x. So that derivative simplifies a lot. Okay, here, some people see ln, they're on autopilot. They're doing 1 over 7 pi times the derivative of 7 pi, and they sit there for a second and think, okay, what's the derivative of 7 pi? Well, 7 pi is a constant. But so the derivative will be 0, but you don't even have to go there because natural log of 7 pi, there's no variables here, no x. So this is just a constant. 7 pi is a constant. Natural log of a constant is a constant. Derivative of a constant is 0, and that's because this is just a number. Like if you go on your calculator and type in ln of 7 pi, you're just going to get a number. So derivative of any constant's 0. So if you need to pause the video to get caught up, then do that. I'm just going to make a comment here. This was a double chain rule. It's like 3 layers there. Okay, example 5. So some people see a fraction bar and they freak out. But this one we're going to use our logarithm rules to make our life easier. So where's my pen? People's first instinct whenever they do this problem, natural log of something, is to do 1 over whatever I did the natural log of times the derivative of that something. Well, I didn't actually do it because I would have to do the quotient rule. In order to do the derivative of this, again, ho-de-hi minus hi-de-ho, all over ho-ho, it's going to get messy. It's doable. I've done it out, and equals the same thing either way, whether you do it this way or the way I'm about to show you. But this is just a little messy with the quotient rule, the layers and chain rule. So let me show you another way. Again, either way works, but just to show you some simpler ways. Where's my pen? Here we go. I'm going to use properties of logarithms. And if I have the logarithm of a quotient, I'm not doing the derivative yet. d dx is just hanging out waiting for the action here. I can expand it. And if I have two things divided, then I'm going to give each its own logarithm and subtract. And if I have derivative of two separate terms being subtracted, you can, this step isn't really necessary, but just to make it more complete, I guess, I can do the derivative of each one separately. And now these are way easier. There's no more quotient rule needed. It's just a very quick natural log derivative 2 times. The derivative of natural log of x plus 1 is 1 over x plus 1 times the derivative of x plus 1, which is 1, minus derivative of natural log of x squared plus 8 is 1 over x squared plus 8 times the derivative of x squared plus 8. Derivative of x squared is 2x. Derivative of 8 is 0. So I just have 1 over x plus 1 minus 2x over x squared plus 8. And if this was a multiple choice AP problem, you might have to get common denominators here. But just for the sake of right now, I just want to practice the ln derivative rules. All right, that's all. We'll practice this in class.